In this chapter, we'll be solving systems of linear equations graphically. So before we graphed them using the addition method or the elimination method and the substitution method. So now we're going to do them by graphing them. So remember that the solution to a system of linear equations is an xy coordinate, which is the coordinate where the graphs intersect on the graphs. Okay, so for example, let's determine if each ordered pair is a solution to the following system. So we have x plus 2y equals 2 and x minus 2y equals 6. So for the first one, let's plug in to x plus 2y equals 2. And this represents an xy coordinate. So the x value is 4 and the y value is -1. So plugging them in here, we're going to have 4 plus 2 times -2, or -1, equals 2. That gives us 4 minus 2 equals 2. So that one does work because we get 2 equals 2. So let's try plugging it in the other one also. So it's x minus 2y equals 6. So plugging in 4, plugging in -1. This gives us 4 plus 2 equals 6. So it gives us 6 equals 6. So since it worked in both of them, that means it is a solution. Let's try the other one, -4 comma 3. So we're going to plug it in x plus 2y equals 2. And plugging in -4 into x and 3 into y, we want to see if this works. So we get -4 plus 6 equals 2. So this one does work, so 2 equals 2. So now plugging it in the next one, it was x minus 2y equals 6. So it's going to be plugging in -4 into x and plugging in 3 into y. So we get -4 minus 6 equals 6. This one gives us -10. So that does not equal 6. So that means this xy ordered pair is not a solution to this system of linear equations. So let's graph these. So x plus 2y equals 2. I'm going to graph these using the y-intercepts. So for the first one, x plus 2y equals 2. If we plugged in a 0 into y, that'll give us the x-intercept. If we plug in a 0 into x, that will give us the y-intercept. So that would give us the graphs x-intercept of 2, a y-intercept of 1. And we get this for our graph for x plus 2y equals 2. The next one, it was x minus 2y equals 6. The x-intercept will be 6, and the y-intercept will be -3. So that'll be this point and this point. So that'll be the graph of that line. And this point of intersection right here is the solution, which was, we saw in that first example, 4 comma -1. So the solution to these systems of linear equations are these points of intersections on their graphs. Okay, so we're just going to be doing these by graphing now. So to solve these by graphing, we're going to graph each equation separately like we just did. We're going to find the coordinates of the point of intersection, and we can check these by plugging them back in the original to make sure that they work. So for example, let's solve this first one. We have 2x plus 3y equals 4 and 3x minus y equals -5. So let's solve this using intercepts here. So let's do that first equation. So 2x plus 3y equals 4. So finding the x-intercept, that means we're going to let y equals 0. And solving that for x, that's going to end up giving us 2x equals 4, which gives us x equals 2. Okay, and now finding the y-intercept for it, that means we're going to let x equal 0. And then we're going to solve this for y, which gives us 3y equals 4. Divide both sides by 3. We get y equals 4/3. So we can plot this. It'll be 2 and 4/3. So here is x equals 2. 4/3 is 1 and 1/3. So I'll put that right about here. So this is the graph for 2x plus 3y equals 4. So remember, we only need the 2 points to graph a line. You could have got this in slope-intercept y equals mx plus b form also and graphed it that way. Let's do the other one now. So let's find the intercepts for 3x minus y equals -5. So for the x-intercept, we're going to plug in a 0 into y. And that's going to give us 3x equals -5, which gives us x equals -5/3, so kind of a messy one again. And for the y-intercept, we're going to plug in a 0 into x. We get -y equals -5, divide both sides by -1, we get y equals 5. So graphing this will be the x-intercept -5/3, y-intercept of 5. So here is the y-intercept, and the x-intercept -5/3 is -1 2/3, so that'll be about right here. And then we connect them, and we will get that line for this one, and then we look at where they intersect for the solution. So they intersect right here, and it looks like this coordinate is the coordinate -1, 2. So what we would want to do here to double check is we would want to plug that into both of these equations separately and make sure that it works. And if you plugged them in both of them, we would see that it works. So I'm just going to rewrite it down here and circle that as our solution. Okay, so there are 3 types of solutions to linear systems. If we remember this from doing the elimination/addition method and the substitution method. So that example had 1 solution. We call those consistent systems, which are independent. A system of linear equations can also have no solutions. If it has no solutions, we call it an inconsistent system, and the equations are independent. Or lastly, it can have infinitely many solutions, which is a consistent system, meaning the equations are dependent. So let's see what that means in a way that might make more sense here. So if we have 1 solution, that means the lines intersect at 1 point, which is what we just did. If there are no solutions, what that means is that the lines are parallel. So parallel lines will never intersect. If there's infinitely many solutions, that means the 2 lines are actually the same exact line, so they're identical, so they fall right on top of each other. So these are the 3 different cases here. And you can see down here in their graphs, here's 1 solution down here. Here's the lines being parallel, and here are the lines directly on top of each other. Okay, and just a reminder, 2 lines are parallel if they have the same slope and a different y-intercept, and 2 lines are identical, meaning they're the same exact line, if they have the same slope and the same y-intercept. So that'll just be the same exact equation. Let's do a couple more examples here. So we have solve this by graphing 2x plus y equals 2 and 2x plus y equals 8. So for this one, let's do this one a different way. Let's get these in y equals mx plus b form. So getting the first one in y equals mx plus b form, all we have to do is subtract 2x on both sides, and we get -2x. So y equals -2x plus 2. And the slope is -2, which is -2/1. And the y-intercept is +2. And then for the other one, we have to subtract 2x once again. We get -2x plus 8. And the slope is -2, which is -2/1. And the slope is, or the y-intercept rather, is 8. So the slope is -2 and the y-intercept is 8. So just by looking at this without even graphing it, we should know what's going to happen based on the previous page. But let's graph the first one, -2x plus 2. So we have a y-intercept of 2, slope of -2, so we go down 2 to the right 1. And we get that graph. For the next one, -2x plus 8, y equals -2x plus 8, We said it was a y-intercept of 8, slope of -2, down 2 to the right 1. And we get these two lines. It's pretty clear that these are parallel, so this is the notation for parallel when they're parallel. We have the same slope, different y-intercepts, so they're parallel lines, meaning there's no solution. They're never going to intersect. Okay, and then another one here, we have 2x plus 5y equals 1, and 6x plus 15y equals 3. So let's do these ones using the intercept method. So 2x plus 5y equals 1. Finding the x-intercept for it, we're going to plug in y equals 0. So that's going to be 2x plus 5 times 0 equals 1. That gives us 2x equals 1, which is x equals 1/2 after we divide by 2. For the y-intercept, that means x equals 0. That's 2 times 0 plus 5y equals 1. Solve it for y. We get 5y equals 1. Divide both sides by 5. We end up getting y equals 1/5. So let's do the same thing for the other one now. Finding the x-intercept, so we plug in a 0 into y. And we get 6x equals 3. Divide both sides by 6. We get x equals 3 over 6, which is 1/2. And then y-intercept, we plug in a 0 into x. And we solve this for y. That'll simplify to 15y equals 3. Divide both sides by 15. We get y equals 3 over 15, which simplifies to 1 over 5. So once again, let's compare these. We have the same x-intercept as on both of these, same y-intercept. So when we go to graph these, they should be the same thing. So we have an x-intercept of 1/2. So that's going to be about right here. A y-intercept of 1/5. So that's about right here. So pretty close together. So we get this line, and this line represents both of them because they ended up being the same exact line. So they ended up having the same slope. We didn't do it the slope-intercept way, but they obviously have the same slope, same y-intercept. So they are the same line, so there's infinitely many solutions. But the way that we can say it, we can also say same x-intercept, same y-intercept, so they're the same line. Last example here, we have -3x plus y equals -3 and y equals x minus 3. So let's do these ones the slope-intercept way. So the first one, -3x plus y equals -3. So solving this for y, we would have to add 3x to both sides. We would get y equals 3x minus 3. That would give us a slope of 3. Which would be 3 over 1, and a y-intercept of -3. And for the other one over here, y equals x minus 3, that one's already in slope-intercept form. The slope is 1, which means 1 over 1. The y-intercept is -3. So graphing the first one, y equals 3x minus 3. So y-intercept of -3, slope of 3, that's up 3 to the right 1. So there is the line for y equals 3x minus 3. Next one, y equals x minus 3. We had a y-intercept of -3 and a slope of 1. So that's up 1 to the right 1. So we get these two graphs. They intersect right here. They intersect at the coordinate, it's actually at their y-intercept, 0, -3. So the solution is going to be 0, -3. So their point of intersection is their solution, 0, -3. Okay, so that is it for 8.1.